All right, in this video, we're going to be looking at first-order differential equations that can be solved by separation of variables. So if we have a differential equation written in normal form, like this, that's going to be a key indicator that we might be able to solve this by separation of variables. Now, in the special case where that function on the right-hand side is just a function of x, then you can just move the dx over and then integrate both sides. And you can see here in the notes they say, which is then just the antiderivative of the right-hand side. And then they give this really nice example right here. All right, let's go ahead and look at if you have a function of both x and y. Now you can only have a separable equation if that function of x and y can be separated into a function of x only times a function of y only. Here are two examples. In this first one, there is a exponents rule that if you multiply like bases, you add exponents. Well, if you are adding exponents with one base, it's true that you can separate them with multiplication this way. So we could rewrite this as x times e to the 3x times e to the 4x and 4y, excuse me. And so now this is a function of x times a function of y. However, if there was an addition between those two, there's no way for us to then separate these into a function of x times a function of y. Let's look at a couple examples. Now, when you first look at example 1, you might think that you cannot separate those because there's that subtraction between the two. But let's see what we can do here. All right, let's write this as 1 plus x dy, and let that be equal to y dx. So I added y dx to the right-hand side. I'm going to write dy over dx then would be y over 1 plus x. And we know that then means that x cannot be equal to -1. Another way we could write this is y times 1 plus x to the -1. I now have a function of x times a function of y. This would be a separable differential equation. I'm going to move the y over by dividing. So I get 1 over y dy. And then I'm going to move that dx piece back over to the right-hand side. Now let's integrate both sides. I get the natural log of the absolute value of y equals the natural log of the absolute value of 1 plus x plus c. I'm then going to take e to the function of both sides. When I do that, I get the absolute value of y equals e to the natural log of the right-hand side. But again, that's going to split up into e to the natural log of 1 plus x. And then I can write that as e to the c. Well, e to the c is also just a constant. And then these cancel. And I can drop my absolute value bars on y because depending on what c is, that's going to then determine what my y function is. But let's go ahead and keep these here. And I know that my domain restriction is that x cannot be equal to -1. So depending on whatever initial condition you have, you'll be able to find the absolute value of these things here. Okay, not including 1, so then you can find your interval. So either from -infinity to -1 or -1 to infinity. And then this C out here will give you either a positive or a negative result. All right, let's look at example 2. This is the one that was given in the example, non-example piece. So again, I'm going to rewrite this as dy dx equals x times e to the 3x times e to the 4y. I'm then going to divide e to the 4y with my dy, and I'm going to write this as x e to the 3x dx. I can rewrite my exponent to be negative on the left-hand side, and then I'm going to integrate both sides. The left-hand side is not too terrible, negative 1/4 e to the negative 4y. On the right-hand side, I need to do integration by parts. So I get 1/3 x e to the 3x minus 1/9 e to the 3x plus c. Now, if you can get to this part here, usually you can then decide if you want to plug in, if you have an initial value, or if you want to try to simplify this a little bit further. We don't have any domain restrictions, so this looks like it's going to be a nice continuous solution. Maybe the only thing I do is multiply through by -4. And then notice that this just becomes like 4 times c, so you can just leave that as c. And I'm just going to leave this as my solution in terms of x and y like this, so that I don't have a natural log of this whole piece and then kind of get a little bit icky there. I'm just going to leave it as so.